So we are asked to create the distribution for the left censored and shifted random variable and then calculate its expected value when d is equal to 2.5. And you may be wondering, what was d again? Well, d is our censoring point. Here's the distribution we're given. Here are all the values, and here are all the probabilities. Before we get started, I do want to go over what we already know about the left censored and shifted random variable. We know that it's the non-negative part of x minus d. We also know that it's equal to 0 when x is less than or equal to d. And we know that it's equal to x minus d when x is greater than d. So what do? We look for the values of x that are greater than 2.5, which in this case would be the 3 and the 4. And what do we do with this 3 and 4? Well, we plug these values in for x in x minus d. What do we do with the other values, 0, 1, and 2? Well, since they are less than 2.5 or less than d, then they would all go to 0. Also, since 0, 1, and 2 will result in 0, we add their probabilities. So after doing all this, we get this, and this would be our distribution. So that's part 1. Then the part 2 of this problem is finding its expected value. What do we know about expected value? I want to hear everybody say this. Expected value is the sum of the product of all possible outcomes times their respective probabilities or densities. So the expected value of our left-centered and shifted random variable would be equal to our first value, 0, times our first probability, plus our second value times our second probability, plus our third value and our third probability, which would give us 0, 0.04, and 0.075, which would give us our answer of 0.115.